Okay, today we're going to learn about percent yield. Okay, when we're talking yesterday, the problems we've been working have given you a predicted amount of product, or how much you should make. And so it's known as theoretical yield. It's the maximum amount of product that could be produced from a given amount of reactant. It's an ideal number. It's how much you should make. But as we know, let's talk about like cookies. If we're going to make a batch of cookies, we should make 2.5 dozen cookies for my chocolate chip cookie recipe. But do I really make that many? No, because somebody's going to eat some dough, or my cookies might be a different size, something like that. So theoretical yield is what you should make, but not always what you really make. Actual yield is what is really produced when you carry out the experiment. So when I really make cookies, how many do I really make? Okay. The formula percent yield is the ratio of the actual to the theoretical, but expressed as a percent. So it looks like this. And not everything's there. Times 100. So actual over theoretical times 100. And I even put you little hints right here. Actual is from the experiment. Theoretical is from your calculations. Okay. Okay, we're going to do an example. Here's our equation, and here's the question. If 5.500 grams of AgNO3 is added to excess K2CrO4, determine the theoretical yield of silver chromate. So first thing you always check is to make sure this is balanced, and it's not. So we need a 2 here and a 2 here. Okay, and you always start with what you know. 0.500 grams of AgNO3. And we're going to, if it says theoretical yield, we're going to grams of this. Okay. So grams is on top, grams goes on bottom. Whoops, Ag. Let me erase that. AgNO3. And 1 mole of AgNO3. And then we add this up from the periodic table. Do that right now. I got 169.872. Okay, the next step is moles of AgNO3 is on top. So moles AgNO3 has to go on bottom. And then we're going to Ag2CrO4. And something on the top and bottom has to be the same, so it's moles. And where do we get these numbers? From the mole ratio. So this one, AgNO3 is 2, Ag2CrO4 is 1. All right, last step, we're going to grams. So moles is on top. And then we go to grams, and I'm out of room, so I'm not going to label, but you be sure and label. So if we're going from 1 mole to grams, we have to add it up on the periodic table.
Oh, I have your cooler. I stole your ice. I'm sorry. Y'all been looking for it? So cute.
Okay, and I got 331.562. I'm sorry, 331.728. Okay, my writing is super messy, so I hope you're writing this on your own. Now, what do? We multiply across the top and divide by the bottom. Don't forget to use your parentheses so you don't make a mistake. And we'll get an answer of 0.488 grams of Ag2CrO4. Okay, so I'm going to write that, oops, I'm going to write that up here because I'm fixing to have to erase all that. So 0.488 grams. Okay, now I'm going to erase this. I hope you wrote it down. If you didn't, back up the video and watch it again. All right. If the actual yield was 0.455 grams, calculate the percent yield. So remember, percent yield is actual over theoretical times 100. So we'd have 0.455 over 0.488 times 100.
Oh my word. You've always had a good time.
Then we get 93.2%. Super easy. Okay, in real life, percent yield is used. It can be used to reduce costs. If you know that you're making tires and that part of your rubber for the tires goes to waste, if you know how much of it goes to waste, you can order that extra without ordering too much. Okay, manufacturers create needed amounts of product with minimal waste. All right, that's it. That's all the lesson for today. Do your homework. If you have any questions, watch the video again, or email me and I'll answer as soon as I can. And then also don't forget,